Hi everyone, today we are excited to introduce MetaTown, our initiative to construct a unique 2D real-time interactive meta universe. Our project MetaTown is a fully integrated 2D virtual world, combining real-time audio, video, chat, and spatial interaction to deliver a fluid, intuitive, and engaging communication experience. Our goal is to create a digital space where the presence and collaboration feel nature and seamless. Technically, MetaTown is engineered for real-time performance at scale. Our core objectives are threefold. First, enabling the large conference rooms features like the low latency voice, video, and the reliable screen sharing. Second, deliver a high-performance 2D game-like office environment, ensuring the data consistency and seamless concurrent synchronization for 20 to 30 active users. And third, all core UI components are custom built from scratch. So these pillars form the backbone of a performant and extensible virtual world.
MetaTown has several core features. The first one is customizable virtual space. Users can customize avatar use arrow keys, WASD to move in a 2D map like a game. Users can design their own 2D spaces with walls and other interactive objects like entry and podium. Multiple rooms can be created within a single space, allowing for private discussions or breakout sessions. Next one is proximate-based video and audio. Just like in real life, you only hear and see people near your avatar making conversations more natural. Walk up to someone to chat or move away to mute yourself automatically. The third one is interactive objects and tools. Instant messaging in the chat window, open camera and microphone to start video and audio communication and send emojis during the meetings. Share screen and record audio. Also, MetaTown is easy access and no download required.
In this part, I will talk about how we create virtual world interaction. Our goal is to enable smooth avatar movement on a large dynamic map. At first, we use pane sets and image elements to display map tile. But as the map grew larger and more user joined, performance dropped significantly. For example, with a 100 by 100 tile map, the app became almost unusable. Zooming and panning become very laggy. After investigation, we found the root cause. There are too many DOM elements were triggering expensive layout and replaying operation. Next page, please. To solve this, we refactored the stage into Canvas API. Instead of rendering thousands of DOM nodes, we use Canvas to draw tile directly. With this change, the app can now handle 1,000 by 1,000 tiles without too many pressure. Thank you to GPU acceleration, the interaction remains smooth even on low-end devices. Inside the stage, user can move their avatar freely. You can see the draft on the left-hand side. We build a dynamic viewport system that keeps the avatar center and handle map edges to keep them visible. We also develop a custom logic to handle the collision detection between avatar and walls, making the interaction feel more natural. For avatar design, we use spreadsheet to create a classic 2D game style. We animate avatar by drawing different frames of the square image as they move. Finally, we enhance the experience with WebSocket. It delivers real-time update for avatar movement and emoji reaction. This made the virtual world feel alive. We can see the user action in real time. By combining Canvas, spreadsheet, and WebSocket, we achieve a smooth, scalable, and fun experience.
Next page. Now, I'd like to briefly introduce the core technology that powers our video conferencing system. MediaSoup, a cutting-edge WebRTC framework built around a SFU, or Selective Forwarding Unit. As you can see in the picture on the right, each participant sends just one video stream up to the server. The server doesn't do any heavy processing. it simply forwards those streams to the others. This setup brings two key advantages. First, it keeps things light on the client side. Unlike peer-to-peer systems, which you can see in the image on the left, where each user has to send multiple copies of their stream to every other participant. Here, they only need to send one stream to the server. Second, the server doesn't need to decode or mix any media, like a MCU would. That means much lower CPU usage on the server side. Altogether, this makes the system far more efficient and much easier to scale as more people join the call. To support the large-scale video conferences, we need to reduce the bandwidth usage and better manage audio and video playback. The problem was that when many participants join a meeting, the browser will still contain all video streams, even if most of them were not on screen. This caused unnecessary bandwidth usage and increased the rendering load. On top of that, we want to separate audio from video, so users could still hear everyone, even when videos were hidden or disabled. To solve this, we reflect our meeting layout and use React's Create Portal to dynamically insert video elements into the DOM or DOM only when they were visible. This allowed us to keep audio playback active while keeping the rendering of hidden videos. And as a result, we significantly reduced both bandwidth and CPU usage, especially in live meetings with many participants. Now, in our case, we add one more thing, recording. We use the browser's Media Record API to record the session locally. Instead of recording on the server, we capture the remote video streams directly in the browser and save them as a media file, like a MP4 file. It's lightweight, doesn't add any server load, and works seamlessly with the live stream. Also, it's real-time, so the browser handles sending, receiving, and recording, while the server just takes care of routing the streams. And one challenge we faced during the next page, the emoji picker. So the one challenge we faced during our agile iterations was the emojis picker component. At first, we rendered the thousands of emojis all at once when the component loaded, which caused the slow rendering and noticeable lag, especially when switching between categories. We first noticed this in our unit test, where one case took over 15 seconds to complete the test case. So clearly point to a rendering bottleneck. To fix it, we implemented the lazy loading using the intersection of server API. As users scroll, only the emojis currently in view are rendered, so this greatly reduced DOM overhead, improved the performance while scrolling and switching categories, and made the emoji picker much more responsive.
In our meeting page, we've greatly improved the chat experience to support real-time communication and rich text formatting. The messaging system is space-specific, meaning that the messages are only visible to participants who have joined that particular space. When a participant clicks that chat button, the system fetches all messages associated with that space and displays them in the chat panel. To ensure real-time updates, we use SWR subscription to listen for changes in the messages table. This allows all participants to see new messages instantly when someone sends one. We've also integrated TipTab to support rich text formatting. The users now can type and send messages with bold, italic, strike-through, inline code blocks, as well as order and unordered lists. This gives users much more expressive freedom when communicating. We've also improved the interaction flow, pressing the enter to send the messages immediately. And after sending, the chart scrolls automatically to show the latest message, providing a smoother and more intuitive experience.
I would like to share how our team used the Agile method to successfully deliver this project. First, let me briefly introduce Agile and its benefits. Agile emphasizes flexibility, continuous feedback, and rapid iteration. By breaking down large goals into smaller tasks and frequently reviewing our work, we were able to quickly adapt to changes, improve collaboration, and ensure that we deliver high-quality features on time. This is the screenshot of our project's roadmap. You will notice that we broke down the entire project into many small tasks, which is around like 232 tickets in total. Through multiple iterations, we gradually assemble all pieces into this one project you see today. Next page, please. I will now demonstrate how we specifically do that. The first example is our emoji picker. We use 4 tickets to refine this feature with different team members participating. We first developed a simple UI component for the emoji picker. Later, we implemented a broadcast logic to send emojis to other users. Finally, when we noticed performance issues, we created a new ticket to optimize and fix them. You could check the GIF here. I am the black cat, and I can see the other users sending the emojis. Please click on the GIF. Yes, thank you. Yep. And the second example is the debunk search bar. Within this one single ticket, we also split the work into 2 pull requests. In the first one, we complete the basic search space function. And then in the second pull request, we add the debunk enhancement to this search function. So you can also see the GIF here about how the debunk search function works.
Okay, let's move on to the live demo.
Okay, let's begin by quickly navigating through our homepage. As you can see, it provides a comprehensive overview of MetaTown's features and the core functions. To dive in, please click the Get Started button, which leads to the registration interface. For existing users, a quick click on the Login Now takes us directly to the login screen. Once logging, we return to the homepage. From here, clicking Go to Spaces button will lead us back to our Spaces page. Okay, now let's look at the personalization function. Users can easily access and edit their profile, customizing their avatar and personal details to reflect their identity within the MetaTown. Next, user can click the Create Spaces button. Then a brand new space will be created. Okay, so here, 100 times 100 map will be set up. Okay, so for your convenience, let's move back to a preset space. Please notice the fluid zone functionality, allowing easy panning and adjustment of the view of the environment. Great. MetaTown offers a set of building tools. A conference room will be sketched with surrounding grass, a floor, and chairs will be placed inside. Great. This particular area is designated as a meeting space where audio is clearly, regardless of distance within the room, ensuring everyone can hear from each other for collaborative discussions. With our space built, an invitation link will be now generated and sent to our team's Slack channel. So please, everyone, please join in our space. Great. You will see our team members joining the space shortly, ready for communication. Okay, thank you guys. Let's demonstrate our general spatial audio feature. As the operator moves away from the team member beyond a certain range, their voice will become inaudible. This highlights the distance-based communication in MetaTown's open areas. Okay, now let's all gather in our newly built conference room. Please go inside the classroom, please. Now, let's gather in this room, and everyone, please enable your cameras. Great. Let's turn on microphone and hear a collective hello everyone from the team.
Hello everyone. Hello everyone. Hello everyone.
Great, thank you guys. And to showcase our interactive communication tools, observe as everyone expresses themselves instantly using our emoji reaction feature. It's a fun and engaging way to respond non-verbally. Thank you. Next, let's move to our chat functionality. You will see the messages appearing in real time, and we can also demonstrate the various font customization options available, adding a personal touch to the communication. You can bold it, and you can also insert the code format. And then for quick oversight and management, our participants panel clearly displays everyone currently active in this space, providing a comprehensive view of all present users. And then for seamless collaboration, MetaTown supports integrated screen sharing. A screen share will now be initiated. Additionally, for documentation or review, we offer a built-in recording function for sessions. Currently supported as a local download in Chrome. Thank you. Finally, to conclude our demo, the operator will demonstrate exiting the current space and then logging out of the platform, showing the smooth and secure transition out of the MetaTown environment. Thank you very much.
Jason?
In the next phase of development, we aim to make MetaTown more interactive and practical. For multiple player interaction, we'll introduce game-like features such as interactive doors, editable whiteboards, objects like furniture and plants, pets, and even vehicles, enriching the environment and the user experience. For messaging, we plan to implement a Slack-like thread conversations, read message indicators, and file uploads to support virtual office use cases. On the video side, we will explore AI-powered background filtering and live transcription to make meetings smarter. Finally, in the alpha testing stage, we'll integrate a payment system and fine-grained space control, allowing different privileges like the number of invitees based on subscription level. And these updates will help MetaTown evolve into a more immersive and sustainable platform. Thank you.